Hello everyone, welcome to today's session. Today we are going to dive into RAG from scratch and basics of fine tuning. These are the most important concepts, and we have a great speaker here with us today, Gautam from ECA, and he's going to go through this session and break these concepts down for us. So, Gautam, are you excited to take this session and share your knowledge with all our curious participants and students?
I'm ready.
Okay, so you can start it
Can I
whenever you're
start?
ready. Mhm.
Can I start sharing the screen?
Yes, yes.
Okay. Hello.
Uh-huh.
Can I start?
Yeah, you can start. Can you turn on your video as well?
Actually, I'm teaching in laptop, iPad. Sorry, iPad. So I'm connected my iPad and MacBook, so I can't turn on my video.
Okay, it's fine.
Yeah. Good morning, everyone. My name is Gautam. Today we are discussing the topic called RAG. Uh, let's go to before going to RAG. Let's discuss how the LLMs will work. Generally, let's take ChatGPT. We all use ChatGPT, Gemini, Claude daily. But what happens in the background and like when you give a query, how does the output come from and where it come from and how it internally works? Let's discuss. So we are the user. We gave a query to the LLM. The LLM will produce output. So it like we are giving the query in natural language, human language, English. So the LLM doesn't understand the natural language. It only understands the numbers, numericals. So when we are giving the query will break into chunks or tokens. Let's say I have a query. What is machine learning? This is a query. So when we give the query to LLM, it will first break the sentence into tokens. Let's say this is one token and this one and this is one. So it will break the sentence into tokens, and it will assign unique id. It will assign unique id to each of the tokens. And the LLMs are built on the like the modern LLMs which we are using. Those are built on the transformer architecture, where we use encoder and decoder model. So we will use the transformers will use encoder and decoder. And if at all like this is a sentence, uh, let's say we are at this position, the LLM will predict the next word using the previous words which we have gave. Like the decoder will like it will decode. Like at first we will train the sentence using
Bro, 1 second. Hello,
net.
hello, 1 second.
Okay.
So, actually, are you sharing something? I can only see the StreamYard thing.
Yeah, and like screen mirroring. I'm
Okay, can
sharing.
you 1 second? Bro, your screen mirroring is not working. I can only see the StreamYard thing.
Okay, one second. Is it visible?
I can only see StreamYard again. I can't see anything else. Bro, a private chat, can you close it?
Oh,
On the right side, there's a chat now. Can you close it?
sorry, sorry. Uh, like where is the option? Okay.
Ah, okay.
Oh, wait a second. Hello.
Yeah, it's visible now. It's visible now. Ah.
Yeah, okay, okay. Sorry, guys. So before going to the rack, let's understand how LLM works. Uh, when we are giving query to the LLM, it will generate the output based on the query which we have gave. So internally, what happens and how the query will go to the LLM, how it will generate output. Let's discuss it. When we are giving a query, it directly don't take the query, like directly don't take the entire sentence and generate output. It will break the query into tokens or words, and like after it will after it break the sentence into tokens, it will use the transformer model to predict the next word for the previous words which we have given. And while generating the sentence, it will when the LLM generates the output, it will not generate the entire output at once. Like if we gave the query to it will generate the entire sentence, but like which we have seen, like it will generate the entire output at once, but internally it does not generate the entire output at once. It will generate word by word, by like, it will take the previous words and it will predict the next word, what comes the next, like that it will generate. And so what are the disadvantages of LLM? Let's discuss it. So LLM is trained up to some specific point. Like let's say if we take GPT, it is trained up to August 1. Let's say like we take some date, so it will train up to some point. Like when you ask the query about the present news or the present which present news or present something anything, so if you ask the question, it will not generate the output accurately. Like the model, the LLM will hallucinate, LLM will hallucinate and it will it will give the output, even if the LLM don't know, it will generate the output using the data which it is trained. And the major disadvantage is, if you have a startup and you have your data, like let's take if you have owned a company and the company will have some private data which you cannot share it publicly. And if you once again, yeah, uh, like if you startup and the data of the startup is private, you cannot directly give the data all to the LLM. So instead of that, you will take some uh, databases and you will store that database, and based on the query which you gave, you will retrieve the specific data and you will give it to the LLM. And so here comes and you will also have another technique which is fine tuning. What does this fine tuning mean? Basically you will take some model, whether it is open source model or any LLM, or let's take llama. We will take some model and you will train this model on a specific data set or a specific domain. Like if we take company, you will have data set like customer support, where the data contains some queries, FAQs, or anything else. And you will gather all those data, and you will take the data and you will also take the model and you will train the data set for this model. Like you will update the weights of this model. The weights are like let's say llama contains 80 billion model parameters. You will update those model weights using this specific data set, so you can accurately get the output for the queries or FAQs or anything. And what are the disadvantage of fine tuning? uh, like if you take uh, this is a 80 billion model parameter. If you train those model, then it will, like, you need to have GPUs, and it will be time consuming, and the computation power increases. So it's very difficult to train the whole model. And there are few techniques like PEFT, parameter efficient fine tuning, where you will not update all model parameters. Like if there are 80 billion parameters, you will not need to update all those parameters. Instead, you just need to freeze the model parameters. And you will take new data set, and you will update those data set, and like you will add new weights to the old weights. Instead of training the whole 80 billion parameters, you will just need to add new weights to old weights. And you will, like, there are techniques like LoRa and QLoRa. These are the techniques where you will like this will reduce the cost efficiency and time which we are consuming by directly training 80 billion parameters. And this is not the like it is also not the best way. So instead of this fine tuning, let's go with rag. What does this rag mean? Let's say you have external data, either it can be company specific data or any pdfs or any data. So you will store the data in some database. let it's not just normal database, something like a vector database. So when the user gives the query to the llm, instead of directly giving the query to the llm, let's first search in the vector database. Based on the query, we will search in the vector database and we will retrieve some relevant information from the vector database. And those retrieved information plus query, we will give it to the llm. The llm will generate the concise output based on the retrieved input information and query. So instead of directly giving query to the LLM, we will just retrieve some relevant information from the vector database and we will give those retrieve information plus query to the LLM. Based on that information, the LLM will generate some accurate output. So there are two phases of RAG. One is indexing or ingestion, and another one is generation. Let's go with what is indexing. So initially you have some raw documents. So you will take some raw documents and you will do chunking. Like you will if you have some, these are the sentences, instead of taking directly those sentences, you will break the sentences into few words or some few characters. So you will chunk the data. So after chunking the data, you need to create embeddings. You need to create embeddings and you will store those embeddings in the vector database. So this is a pipeline of indexing. Let's go deeply and understand how this will work. Suppose I have a sentence like this is the sentence. Yeah, this is a sentence. And let's go the step by step how the chunking works, how can we create the embeddings, and how it will be stored in the vector database. So if I have chunking, if I have a sentence like this, so first we need to break this sentence into words. Let's say we have uh, 6 words, and there are few terms called chunk size and overlap. We'll discuss what is mean. uh, Chunk size mean like number of words we take. Let's say if chunk size is 3, then we need to consider 3 words. This is a 3, and so we need to take three words, and we need to split the sentence into those 3 words. And what does overlap mean? If I take chunk overlap equals to 2, we have chunk size equals to 3 and chunk overlap equals to 2. Let's divide this. Okay, this is the chunk one, and when we are generating the next chunk, we need to check the overlap of this chunk. If the overlap is like let's say the now the overlap is 2, so we just you should not take the chunk from starting this index, because the overlap is 2, so you need to overlap the chunks with the previous chunks. So this is the overlap. So when we are taking some overlap, the chunks like the context will not break totally, so we can store the like we can maintain some relationship between chunks. So that's why we need to check some overlapping. And after chunking, we need to create embeddings. uh, so after those chunking, and we like there are few NLP techniques. uh, there are few NLP techniques, natural language processing. First one is bag of words, next TF-IDF, next what to wake. These are the techniques which we will use to convert the words into embeddings. Like now we will take what to wake. It will have two variants. One is continuous bag of words, and next one is skipgram. We will discuss continuous bag of words and how it will work. So we have a sentence. We have a sentence. I love machine learning very much, and let's use continuous bag of words to generate embeddings. So what does this technique will do, let's discuss. And like if you are at some word, let's say if I am at word machine, you will take the words which are prefix and suffix words, like which are before the word machine and after the word machine, and you will create a data set for that. uh, as of now, and like there will be some term called window size, which will decide how many words we have to pick from previous and how many words we need to pick from suffix. Let's take window size equals to 2. So if we take the window size 2, I need to pick like these are the two words after and before the machine. So if the window size 2, so this is the sample data, or we can say input, and we can say this is an output. Basically we will take the words which are like we will predict the word by using the surrounding words. If at all, if it is word is in the middle, then we will take the surrounding words, left and right words, and we will predict those words using the surrounding words. So similarly, we can form few more we can form few more samples. uh, Similarly, we can form few more samples, and now it will become a data set. So we need to train some model so that the input and output should be like accurate. Like we need to predict the word machine using the words which I love machine very. So let's take a neural network. So before that, we after generating a data, you need to give some IDs to the words. Let's say I have six words, six unique words. So I need to give few IDs for that word. So I will take from 1 to 6. You will need to some give some IDs, and let's take the first sentence. This is the first sentence, and you will generate some vector for every word. Let's say for this word I will take some vector, and this word I will take some vector, similarly those words. And there's a technique called one hot encoding. The total number of words in the sentence are 6. So which the word which you are taking at that position, you need to fix the one position, and remaining you need to fix 0 positions. Let's say I am picking the first word, so this will become 5 zeros. And similarly, if I take the next word, you will indicate it as like this. And similarly, the next was also. And by and the you will have some output, like uh, by above the by looking at the above data set, you will have the output for the first sentences machine. So you will train the model by using the input, and you will update the weights, and you will train the model to get the output machine. So by using one hot encoding, you generated these vectors, and you will take a neural network where these will be inputs, and this is the hidden layer, and this is the output layer. The input layer takes the take the vectors which you have generated, like 1 0 0 0, and similarly you will take this vector, and similarly you will also take here also. And these are the neurons, and all these are neurons. And you will train them, like initially you will take the random weights. Initially you will take the random weights, and you will start training the neural network. And after getting the output after getting the output, you will check the output with uh, actual output which we have in the data set. You will compare those outputs, and if the outputs are not similar, you will calculate the error. And again you will do back propagation. Back propagation means you will update the weights again according to the error. You will update the weights according to the error. And again after updating the weights, you will again forward propagate, and you will check the output. And if it is not okay, then again you will back propagate. So this process will continue until you will get an accurate this process will continue until you get accurate result. Is my screen visible?
No, it's not visible. Did you stop sharing?
um, Now
It's visible now. Okay.
Yeah, okay. You will train this. You will back propagate and forward back propagate until you get the accurate result. And after getting the accurate result, you will stop the training. You will stop training the neural network. And after getting that result, like for each word, you will get some vector. For each word, you will get some vector. It's a numerical representation. Let's say for word I, you will get a vector of this is a vector which you will get for this word. And similarly for another, for remaining words, you will get few vectors based on the training. So after getting the words, like after getting the vectors, you need to store that vectors. So this is for one sentence. If you have multiple chunks, let's say you took a document where you have 100 chunks, 100 chunks, and for each chunk you will generate one vector. Similarly for 100 chunks, you will generate 100 vectors. And if you have like every chunk contains some sentence, let's take chunk one is this is chunk one, but you will get vector for every word. So for representing the entire sentence, you will do the average of those vectors. Let's say for word 1 you have this vector, and word 2 you have this vector, and similarly for word 3 this is a vector. So to represent the entire sentence, you will do the average of those. So this will represent entire sentence. So this will represent the entire sentence. And after generating the vector embeddings, you need to store that vector embeddings in some database or any other. So to store these vector embeddings, we have vector stores or vector DBs. So you will take the ID, you will take the chunk, and you will take the embedding of that chunk. So we will store these three columns in the vector database. Like for every chunk, there will be ID and embedding. We will store similar to SQL tables, but we will not use the regular tables. There are some vector stores like Fice and ChromaDB and Pinecone. These are few vector databases. This the retrieval from this vector database will be very fast. When we gave a vector and we start searching in these vector databases, the output or retrieval which we get will be very fast. So this is one phase. And after storing in the vector db, there will be another phase called generation. So when the user gives a query, instead of directly going to the LLM, we will first search in the vector DB. We will search in the vector DB and we will get some relevant information. we will get some relevant information from the vector db, and with that relevant way, and we will take the query press information which we have retrieved from the vector database, and we will give those to the llm.
Your screen sharing has stopped.
Okay, one second.
Ah, it's visible now. It's okay.
Yeah, oh, after retrieving the relevant information from the vector database, you will give the query plus information which you have retrieved to the LLM, and the LLM will generate output based on the query which you have gave and the information which you have retrieved. So the output of this will be accurate, and the model will not hallucinate. So, like how the searching will be done in the vector database, let's discuss how it will be done. So when you gave a query, similarly before we have converted every chunk to a vector. Similar to this, we will convert this query to a vector, like we will convert to this to embedding. So after converting the query to the embedding, you will get some vector like this, and there will be two searches. One is Euclidean distance, and one another is cosine similarity. Euclidean distance in the sense we will find the distance between two vectors. We will find the distance between two vectors. We will use the formula x1 minus x2 whole square plus y2 minus y1 whole square. This is a distance formula. We will find the distance between two vectors, and uh, if there are 100 vector embeddings in vector db, for every vector we need to calculate distance, and we will pick the minimum distance vector. So similarly for cosine similarity, we will find angle between dis- we will find angle between vectors. Instead of finding distance, we will find the angle between vectors, and we will pick the minimum angle, and we will retrieve that information, and we will give it to the llm. So initially you will map id to chunk in some database, and after generating embeddings, again you will map id chunk and embedding in vector db. After retrieving uh, after retrieving the relevant information, after retrieving some relevant information, you will have you will get id chunk embedding. So using this id, we will take the actual information from the database. Like we will before we mapped id to chunk, so we will get those actual chunk, and this actual chunk will be given to llm, and also we will give query to the llm. So in this way, we will generate the output using rag, and we talk about the database. vector database. Let's discuss one of those files. Files is one of the vector database, and there are two different when you are adding the vectors to the vector database. There are two different ways to add those vectors. One is uh, index flat L2, and another one is index IVF flat. So after adding the vectors to the vector DB, so in this L2 indicates Euclidean distance. You will take the query vector and you will find the distance for every vector, and you will pick the minimum vector distance. This is what index flat L2 mean. And if we talk about another, instead of instead of finding distance for every vector, uh, while inserting vector, we will group similar vectors. We will group similar vectors into one cluster. So like there will we will use K-means algorithm, where if we have similar data points, we will group them into similar cluster. This will contains some similar data points. Similarly, in this we will group the similar vectors into one cluster, and while we are searching, we just need to find that cluster, and within that cluster, we will find distance for every vector in that cluster only. Let's see how we will code it. I think it's visible.
Yeah, it's visible.
Okay, wait a second. So yeah, we are taking the document called attention is all you need. This is the transformer model architecture document. So we will take this document and we will chunk those document and store the vectors in the vector DB. So these are the requirements which will be required. uh, PyPDF is used to load the PDFs. Sentence transformers, which where we will convert the sentences into vector embeddings, and files is used to store the vector embeddings. LangChain is used to connect the LLM. So after installing those requirements, we will load the document. Let's say we took the PDF. So we need to uh, import the PDF loader, and we will define the path. Like here there will be path. You just need to copy part, and just need to paste here. And after taking the path, you need to load the document, and you just need to print whether it is working correctly or not. So after loading the document, you need to do the chunking. So there are a few text splitters. uh, as of now we are using recursive character text splitter, and there are a few other splitters where it will split the sentence into chunks. Here we gave chunk size equals to 500 and overlap equals to 50. means it will take the, like if we have the whole document, it will take the first 500 words, and next the next chunk starts from 450 itself. There will be some overlap between these two chunks, and you will initialize that text splitter, and you will split the documents which where you have. And uh, here when we are loading the document, the document structure itself contains uh, wait a second. So we are using LangChain document. The document contains few properties, like few terms in it. One is page content, and another is metadata. So this page contains the actual data, and the metadata contains the it is a dictionary where it contains author, page number, or some other any relevant information, info about the PDF. So this is the structure of document. So after splitting the text into chunks, uh, you will see, like here we will see that there are total 76 chunks which we have splitted. And after splitting the chunks, you will need to load the embedding model. Previously we have discussed it, to convert a word to vector we used word to vec technique. So instead of that, there will be already pre-trained models, like there will be sentence transformer or OpenAI embeddings, chat generative embeddings. So we can use those embeddings directly instead of training from scratch. So here we will use sentence transformer, and we will load the model, and you will you will take the chunks, and you will convert those chunks into the embedding. You will encode the text into vector embeddings, and here you can see the size of the sentence transformer model will be 384 cross 1 dimension. This is the dimension, this is the shape of the transformer sentence transformer model. So where you will contain 384 rows and one column, uh, which are denoted by numericals, like it can be 0 point something like this. They same like this, there will be 384 numericals which will represent those word. And so after generating embeddings, you will store that embeddings in the vector database. Here we are using files, and here let's see. If we see here, we are using float 32, because float 32 takes less computation compared to integer. So we are using float 32, and we will store the vectors in the vector store. And here we can see index flat L2. This is basically when we are searching the query in the vector database, it use Euclidean distance formula to calculate the distance between vectors. And we can also take the top k relevant information instead of picking the top one information from vector database. We can also take 2 3 or any other k number. So after storing that in the vector database, uh, this is a query which where the user gives what is self attention. This is a query. Before directly searching into the vector database, we will convert those query into the vector embedding. We will encode that query, and this is a query embedding, and we will search it in the vector database. So when like after searching the vector database, it will give two outcomes. One is distance and one is indices. Distance mean the distance between two vectors which it has been calculated, and these are the indices. Like, yeah, if we see here, we have used three. Like, it's something like k. If we use any number like 1 2, it will retrieve only that number of indices. If yeah, we have used three, it will retrieve the top three indices which are similar to the input or query vector which we have gave. So these are the indices which we got, and using that indices we will search in the database, or we have stored those chunks in the list. So we will search these indices in the list and we will get the actual. So this is the actual data. So using that index, we search in the list and we will get actual data, and we will build some prompt. Like, this is the prompt which we have built. You will give the input or query, and you will also give the information which you have retrieved from the vector database. So, and by combining this, you will give this to the LLM. uh, okay. You will, here I am using Google Chat Generative AI. So this is a Gemini model. So you need to pick some API key and you need to keep here, and you can use any other models. And you are like, yeah, we are initializing the model, and you will give the query plus which we have retrieved from the vector database, the relevant information. You will give it to the model, and the model will give the output based on the query, and output like it will give the output based on the query and information which we have retrieved from the vector database. So if we run this, okay. So this is the size of the embeddings. So this is the chunks which we have retrieved from the vector database. Yeah, we are using Google Gen AI. So we need to install requirements. Okay. I think the session is disconnected, so it's restarting. Okay, not a problem. Uh, so you will get the output like this, and you can even get more concise output based on the prompt which you have gave. Like, here we have built the prompt, so you can build prompt in such a way that you can get the accurate or you can get the brief output. So that's the end of the session. Hello.
Okay, that was an amazing session. Thank you, Gautam. We are happy to have you here. So, participants, if you have any questions, you can ask in the comment section. Gautam will clear your doubts if you ask him. I guess all the concepts are clear. I guess you explained it pretty well. No doubts from the participants. It means it's clear. So,
Okay.
thank you. Thank you for being here, Gautam.
Yeah, thank you.